Let's do 27 divided by 4. So we're looking at how many 4s we can get out of 27, and we can do 6. So 6 times 4 is 27. We subtract, we get 3. Now in elementary school, what you were told most likely was put a dot here and here. Really, you can put it everywhere. Put a 0, and that means we put zeros here too, but I'm not going to bother with that. And now pretend this is a 30 instead of a 3. So how many 4s will go into 30? Well, we can get 7, because 7 times 4 is 28. We get a remainder of 2. And if we're faithful to put the points, which we don't really have to be, okay, now we put another 0 so we can keep going, and we pretend that's a 20 instead of a 0.2. How many 4s go into 20? 5 times 4 is 20, which is technically 0.2, and we get a 0. Well, why does it make sense to do that? Why do we just put a decimal and keep putting zeros, and we can just keep going, and that makes sense? Here I've made 4 copies of this, and I want you to notice it doesn't make any difference where I put the decimals. As long as they're lined up, these are all true. So keep in mind when you multiply something by 10, it moves the decimal 1 to the right. So if I multiply 2.5 by 10, it moves the decimal 1 to the right and gives us 25, which is 25.0. But we normally wouldn't put that, but we know the decimal was here and it got moved over here. So if I do 4 times 0.675, this is what I get. Now, if I move the decimal point over to here, well, this is just 10 times as big as this, and this is 10 times as big as this, and that makes sense. If I do 4 times something 10 times as big, my answer is 10 times as big. If I do 4 times something 100 times as big, I'm going to get something 100 times as big. If I do 4 times something 1,000 times as big, I get something 1,000 times as big. And so all of these are true. So the fact of the matter is it never really mattered where the decimal was anyway, as long as you remember where it was in the original problem. So really what you could do is if you were, let's do this again. And so I put my 6, I subtract and get 3. What you could do here is just say, I'm just going to pretend this was already bigger anyway. Put as many zeros as you want. And so now this really would be a 30. So 4 times 7, 28. We get our remainder of 2. We could be filling in all these zeros here. Doesn't really matter. And then 4 and a 25, that would give us 20. So we don't even worry about the decimal place. But then you could, at the very end, remember this is where the decimal place really was. So this is my answer. And so hopefully it makes more sense now why you can put a decimal and keep going, because the fact is you never needed to put a decimal in the first place. All you had to do was remember where it was when you began.